Welcome to episode 10 of the Engineering Quality Control Podcast, a podcast focused on helping engineering professionals ensure that they can address quality control on all of their projects and maintain the highest level of quality. Provide strategies and concepts to help you do that. I'm your host, Brian Wagner, a licensed professional engineer, and in this episode of the podcast, we'll be talking with Jason McCool, a licensed engineer and project engineer with Robbins Engineering. We talk about his experience and the things that he's seen as being essentially an intermediary engineer between the design engineer and the contractor. We dive into some of his less than desirable situations and some of the advice that he's come up with over the years. So let's jump right in. So now I'd like to welcome our guest for today, Jason McCool, a licensed professional engineer and project engineer with Robbins Engineering. Jason, welcome to the Engineering Quality Control Podcast.
Thank you. Good to be here.
So I thank you for taking time out of your busy schedule. If you're anything like every other engineer I've talked to recently, we're all busy. But can you tell me a little bit about your career path and maybe how you've ended up where you are today?
Yeah, it's been a bit of a roundabout journey. It actually started in high school when I was supposed to write a term paper my senior year on whatever vocation I wanted to go into afterwards. And at that point, I thought I wanted to go into engineering. And for the term paper, one of the sources had to be an interview with somebody in that profession. I didn't think I knew any engineers, and somebody said, "Oh, I think Wes Myers at church is an engineer. You ought to talk to him." And it's like, okay. So I found him, and he said, "Yeah, come on out to my office, and we'll do the interview." So I interviewed him, and he said, "You asked some pretty good questions. Here, take a job application." So so I actually never had to interview for my first engineering job. I interviewed the interviewer. So but he hired me on for just doing some summer help right out of high school, and then after a couple weeks of doing painting and moving furniture and stuff, then he says, "Okay, come on back here." And he handed me his old college textbooks for statics, mechanics of materials, and steel design, and had me working homework problems the rest of that summer. So before I actually left to go to college, I had already been doing designs and details for reinforcing steel joists. So I got to college, and I sailed through mechanics of materials because I'd already gone through a lot of that in the summer between high school and college. Yeah.
Practical experience, not just
yes.
theory experience of what they're trying to teach you in a class.
Yes, and one of the things that he really focused on was he would give me a bunch of calcs, a bunch of joist calcs, say, verify every number on here. Here's the steel joist catalog with the formulas that we use for compression and tension and bending and whatnot, and verify all these numbers, and then bring it back to me, and I'll take a look at it. So that was actually one of the most practical things. I can't recommend that enough, because in my own experience doing connection design, a lot of times I'm going through the calcs in a program, and I have actually found a lot of bugs in commercial design software that way. So that is actually a very helpful practice to get into. But just verifying and not trusting the computer, not trusting the programmers behind the computer. So they are just as human as us. But,
right.
But yeah, after that, I went to college. I actually got my degree in welding engineering and materials joining. So think metallurgy, robotics, heat transfer, none of the classes that really come to mind when you think of structural engineering. So it's, like I said, it's been a very roundabout journey, but then I kept going back to the joist plant every year for summer, spring break, Christmas, anytime they'd have me. So my design responsibilities there kept growing, and then they hired me on full time. I went out to their Nevada plant, became a design engineer there, passed my PE exam for California, got another like 9 states out west, working out there, and then took over as QA manager, rewrote their QA manual, then became engineering manager a few years later, and then came back out to Arkansas as the recession of 2008 hit. That was particularly hard in Nevada, so they asked me, would you like to move to Arkansas, to our technical office out there? And I said, I would love to have a roof over my head. So yes, I will go wherever you send me. And then a year later, they had shut down. And so I found myself looking for work, and I went to a pre-engineered metal building company in the area. I worked there briefly, but I got another 10 licenses for this central US region while I was there. And then I hired on to Robbins Engineering here in Little Rock, Arkansas after that. And I've been here since 2010. So.
Okay. Nice long stint, which is great. I mean,
yeah,
it's a very unique, I think that so many people come out of school or go into school with this whole idea of they're going to do this or that, and they're making that decision about their degree with really only 5 or 6 years of kind of adult thinking. And they're planning the next 40.
Yeah. I can tell you,
basically, I mean,
I can tell you, I thought I was going to be at the joist plant for my entire career, and things change. So
right.
Be flexible.
Yeah. So, I mean, I got hired, I started doing civil engineering. I always wanted to be an architect in high school and things like that. And I got hired in a civil engineering internship at the vocational school that I was at. And the rest is history. So
yeah,
it got me introduced to civil, and that's just where I've pretty much stayed.
It's funny always looking in hindsight how things turn out way different than we ever think they will.
Right. It's crazy how life takes it. And like I said, I've talked to some high school students that are like, yeah, I need to figure out what I'm going to do. I'm like, no, you don't. Like, just go with the flow and you will figure something out, because you can't make this decision at 15, 16, 17 years old of what you're going to do for 40 years. At least that's my opinion, because it's just so much time.
Yeah.
So for the past several months, I guess, you've had an article that's been published in Structural Magazine or Structure Magazine.
Structure Magazine, yeah.
And you've outlined about 9 different things that you've noted in your career that kind of relate to copy and paste. And I think that's one of the worst things about CAD and the technology that we use, because it's always steal it from another job, take it from this, take it from that. It applied here and it almost applies there.
Yeah.
So can you maybe give the listeners a little bit of an overview? We'll link to all the articles in the show notes, and we can definitely reference them today, but I just wanted to give you the opportunity to kind of outline the ones that you want to talk about today, and then we'll see where we go.
Yeah. Oh, it's funny. Computers have allowed us to make mistakes much faster and more efficiently than ever before. But a lot of the problems I've observed in construction documents, because I'm getting, as a delegated connection designer for different fabricators, they're sending me architectural and engineering, structural drawings and MEP drawings from engineers all over the country. People working out of their house to people working for multi-office, international firms. So I see all different levels of work, and a lot of the problems I found actually come down to how we react to the conflicting goals of speed and perfection. Because as engineers, we want to be perfect. Well, we could have people's lives can depend on whether or not we have a typo on our drawings. So, we're keenly aware of that need for it to be correct, but we also have to get our drawings out in a timely manner. So, we don't want to have paralysis by analysis in the pursuit of perfect drawings, but but our drawings need to also communicate clearly and coherently what our design is. So, reusing past work is often a very good way of speeding up that process. Once you've calced something out, you've made sure it works, you've kind of got a best practice maybe formulated, then you can apply that to future jobs. The problem is when it almost applies. When it's obvious that it doesn't apply, there's no issue because you don't use it. When it almost applies, though, is where we tend to get into trouble because we do use it, and then it comes back and bites us a lot of times. So a lot of what I see kind of results from this overarching attitude of just get something on paper so we can meet our deadline, and we'll fix it in the addendum. We'll fix it later. We'll fix it before the final stamped set. And then things happen.
Doesn't always get fixed.
Yeah. So this can lead to inapplicable details being copied onto drawings, like maybe a high seismic connection. Well, this is kind of borderline seismic design category C or D, so we'll copy this high seismic detail on there, and we'll take it off if it doesn't apply. And then it never gets taken off. And what happens on my end is the fabricator sees this high seismic detail and panics and throws a bunch of money at the project and says, this isn't what we thought it was. Just double the price on this, because if this is what it is, then we're going to be spending a lot of time and money in the shop making these special seismic connections work. So there's that. Contradictory specifications a lot of times make it out the door because one team member was adding details, another team member was copying over some boilerplate specs onto the project, and the UR wasn't coordinating between those two things, and they were going divergent directions, and nobody caught that. So I'll see stuff like maybe AESS, architecturally exposed structural steel, gets noted on a spec, and the drawings never say anything about that. But the fabricator, they do look through our specs. When we put out specs on a project, they are looking through them with a fine-tooth comb, and if they see something like that, they're flagging it and saying, hey, this could be a cost issue here. We need to throw some more money at this. And so it's important for the engineer to be coordinating those different aspects, like drawings versus specs. And if you say, oh, in the event of a conflict, the drawings govern, or some kind of note like that to cover discrepancies, a lot of times that doesn't matter. The fabricator is just looking at what is going to be my worst case. What's going to burn me? Okay, we're going to cover that worst case. So, just having a note to say use this one instead of this one won't necessarily prevent either RFIs or project going over budget, things like that.
I think you're looking at you're taking, if I understand this correctly, so you're taking plans that are designed, and then you're like that interim step before it gets built.
Yes.
So you're the first person involved in that sequence that's going to start pointing things out or start asking those questions because it was just got it on paper, or we thought we might need it, or well, this contradicts with this, but nobody's answered this question.
Yes. Yeah, because connections, like what I do, is one area where the details really matter. So you can make something look pretty good on paper. Like there's what I call eyewash. We have this detail that's kind of mostly done in our library or a template or something. We copied it over to the drawings. It looks pretty good, so we can say, okay, yeah, we're at a 50% set here. or okay, we're at a 95% set here, but we haven't really worked out all of the details. Well, the fabricator has to work out all of the details because they have to build it, and then what they're doing is they're hiring somebody like me to work out, does this need 10 bolts or does it only need 9? Does it need a 1/4 inch thick clip angles, or does it need a 1/2 inch thick clip angles? Things like that. How big a
You
weld
start
do we
adding-
need?
You're starting to add costs in, and
Yes.
not just drawing a pretty picture. It's
because the
and you
picture
may
can
lose
look
out
pretty
on it.
good.
Right.
Yeah.
You might
And a
lose
lot
out on a job because you overbid it or underbid it,
yes.
and then you get into that change order world, and that you have upset clients.
Yes. So there's some of that. Another thing that I've seen, and this isn't a big deal, but it does reflect poorly on us as engineers. I've gotten drawings that in recent years that still reference the 1979 welding code. I've gotten ones that reference the 7th edition steel manual, which in fact, you can see it on the top shelf behind me there. It's that light blue one up there. Most young engineers have never even seen that steel manual because it was from 1970, I think. But it still shows up on like a general note sheet on the structural drawings. And the fabricator sees this and they're like, man, if this is on here, what else did they miss? So it reflects poorly on us as engineers. So I mean, that's something that the fabricator is not going to stress over that, but we need to pay attention to detail in our drawings. And this kind of gets into the quality control aspect of, doing that second look at our drawings and just going through saying, okay, try looking at it with a fresh set of eyes, and and not just blowing off stuff. Oh, they'll figure that out. Oh, they'll understand that's not what I meant there. Well, it still looks bad though.
Right.
So another thing I've seen is clear drawings. They take time to create, and so an easy way around that is to make the drawings more vague. And so a lot of times I get very vague details, and the steel detailer is just like, what on earth does this even mean? Oh, even as an engineer, a lot of times I'm looking at it, you got me. I don't know what it means either. But and the problem is that when it's the vaguer it gets, the more likely it is to apply to a situation that you as the engineer of record never intended. And that's where it really comes back to bite people.
Get scary.
Yeah. Because what happens is, maybe the steel detailer interprets it correctly from what you put down on paper, but it's not what you meant. And so then, you've got to do a really good job on the approval drawing, reviewing the approval drawings from the steel detailer to maybe catch this little thing that changes how that frames up or changes that load path, especially. Nobody wants to be another Kansas City Hyatt hotel, where the load path changes a little bit, but it makes a huge difference. And those details really come into play on that. So vague details is a problem there. Coordination.
Right.
Go ahead.
I was going to say that I think in the third part of that article, I liked your one statement that was reusing details that should have never been used the first time.
Yes.
That coordination and that stealing, copying, and pasting.
Yes, I see details that have probably been in people's libraries for 20 or 30 years, and going to that about details that should have never been used. AISC has strongly discouraged certain details for decades now, and yet I still see them on structural drawings all the time. Things like the through plate connection for simple shear connections. And in the third article, I believe, is where I showed a picture of what a fabricator actually has to do to make that the way it's a lot of times shown on structural drawings. And it goes from just a simple shear tab connection is just a few fillet welds. A through plate connection with intersecting through plates in the middle of a column ends up being multiple full penetration or complete joint penetration groove welds with more fillet welds, cutting up this column, just butchering it. And one thing is, in the shop, it never comes out as clean as it does in Revit or AutoCAD. You can just draw this little nice smooth line for a cut, but in the shop, that's got to be either torched or plasma cut, and it's got to be ground smooth, and then welding, and then to get this plate in here, maybe you need to allow a tolerance so your cut is wider than the actual plate, and now you've got to make up for that difference with your weld size, and it cascades. And you don't see that on the engineering side if you haven't talked to fabricators. But that's actually one of the best things I would recommend for engineers is talk to your fabricator. Talk to any fabricator, even if they're not involved in the project you're working on. They will love you for it. Right. And that detail, the through plate detail that I referenced in the article, is actually what I call how to make your fabricator hate you. And fabricators have told me, yes, that is appropriate description for this. But another thing is coordination. It's not uncommon for me to see details on structurals that say C architecturals or C MEP, and kind of kick the can down the road, and then you go to those drawings and they say C structurals, and you're in this loop. And meanwhile, nobody's actually addressed the issue of how to make these conflicting requirements actually flesh out. So then what happens? RFIs. So it's one of those things where I get that it's extra time to coordinate, and you've got project deadlines and everything, but it is time well spent to try and spend that extra time reviewing those, especially those last minute changes. The architect just sent us their updated set, and we got to get this out now. But so I get it. We deal with the same thing in our office, but those are the times that create the problems that I've found on projects.
So we've discussed a lot of the problems, a lot of things you've seen that affect the ability for you to do your job, the fabricators do their job, the contractors do their job, because it just continues to cascade and trickle down. And I think you had mentioned earlier the speed versus perfection. I know we're always shooting for perfection as engineers, like you said, but you only had to have 70% to get your PE license, which is a little anomaly there. But if every engineer only functioned at 75%, nobody'd be employed very long.
Right.
Because there's a standard above that. But
yes.
Do you have any ideas for engineers and how not to fall into some of these traps?
I wish I could say there was a silver bullet, or a simple thing you could do on your next project. But really, what I've found is, I think a lot of it comes down to kind of like in quality control in general. Like when I was QA manager at the plant, inspection is just simply putting a second set of eyes on the product. And in a plant, it was get an inspector looking at the weld, get an inspector looking at the material, so on. And a lot of times we don't do that in engineering. We kind of tend to be especially once we get past the young engineer stage, now we're like, okay, it's my project, and yep, I'm good with this. And we kind of lose that that uh,
That
that's
review, really. That
yeah.
revisiting, relooking at it.
And we're used to that as young engineers. We're okay. I'm going to have the guy that's actually reviewing my stuff as an intern and is in charge of it, responsible for it, stamping it. I expect him to review it. But then once we get our license, it's like, oh, okay, well, I don't need to worry about that anymore.
Now it's your problem.
Yeah. And so I think just having a second set of eyes, whether that's a colleague or one thing I would actually suggest is kind of an intergenerational review. We tend to think of the more experienced engineer reviewing, but I would suggest you can also benefit from having the young engineers or interns look over the drawings of the more experienced engineers, because it's kind of a two-way process for them. They have a chance to see how somebody experienced is doing it and learn from it. But then you also tell them, I want you to think critically through this and ask any questions, A, so you can learn, and B, because you're bringing a whole different perspective to it. You're not coming to it with I've been doing this for 20 years. I already know what works. I proved that 10 years ago. I did that calc 10 years ago. I know, well, maybe things have changed. Maybe the code's changed. Maybe this new engineer has been exposed to some things now, that you weren't. And so I think that can be helpful. And the other thing is actually going through things like connection design. Like that's one that gets delegated a lot. And what it tends to do is just push the problem off on somebody else to solve. And I think even if you delegate something for the rest of your career, go through it at first before you start delegating it, so you have an idea of the impact it has. Because I've gotten stuff where somebody delegates something and they say maybe a beam to column connection, and their program, whatever program they're using for their analysis, it says, yeah, you can use a 8-inch beam, 8-inch column here, and you can use a 21-inch deep beam. And then they put a note on their drawing saying, all moment connections to develop the full moment capacity of the beam. Well, your moment capacity for a 21-inch deep beam is way more than you can develop out of that 8-inch column. So then but if you never have to deal with the consequences of that in the connection design, then you don't even realize the problem you've created until you send it to the fabricator. They send it to me, and I work out this monstrosity, this ugly monstrosity of a connection that is technically possible, but not anything anybody would ever want to actually fabricate or erect. And it's like, okay, here you go. This is what meets what you said. Maybe not what you meant, but it's what you said on the drawing. So here you go. So, but if you do that, even just once or twice, just something, so you say, oh man, this is a bad idea, that will pay dividends on every job you work on after that. So those would be like a couple of ideas I have for how just colleague reviews, bringing in younger engineers and interns into that review process to get them thinking critically and to also get their perspective, and then working through whatever you're going to delegate, whether that's structural steel connections or cold form steel or whatever it is, getting some practice on it. And you may not have all of the tools. Like I've got some specialized tools for expensive specialized software for connection design that the average engineer of record probably isn't going to have. But a lot of it is still doing the basic, AISC connection calcs, the formulas and whatnot. So it's just doing it very fast and
Right.
very
I mean,
optimized.
I think a lot of engineering is very fundamental, very
Yeah.
basic in thought process. You do this and this happens, or
Yes.
this or that. And then we overly complicate it. Arnold Palmer, I don't know, do you golf? Arnold
I
Palmer
don't.
said that golf is extremely simple. Like you hit the ball and you go find it, hopefully. But how
Yeah.
you actually execute that is extremely difficult. I've seen that with stormwater. I'm sure you've seen it with connection. Like it's very simple to say it's this or that. Stormwater is very simple from the context of you clean the water and slow it down. That's
Yeah.
all stormwater is. Drainage is just pass it through, get rid of it.
Yeah.
Sediment control is clean the water. Like it's very fundamental, but how we execute it as engineers can be quite complicated. And then you throw in, and as you were explaining some of the things you were just mentioning there, I was just thinking about the power of Excel and how it has made so many people dumb because they're just plugging in numbers because they've done that equation 300 times, 500 times, 5,000 times.
Mm-hmm.
And the experienced engineer that has been through that process and went through that math and done it longhand, punching all those numbers into the calculator like you did when you were coming out of high school, you know what that answer is going to be before you finish typing it all in, or at least a gist of what it should
Yeah.
or shouldn't look like.
It helps you
So many
develop
of-
that engineering judgment.
Right. For so many people that I see now that are younger, that are just plugging it into a black box of a software, and like you said, you found things that are wrong with software. You know what it might be before you finish, and they're just going to keep going.
Yeah.
So I think that's a nice word of caution for all of us as engineers, no matter where we are in our career.
Yes. I agree.
So I just I want to be conscious of your time and not take too much of your time because I know you're busy, like I said. But we have listeners of all ages, some that are early in their career, some that are well established, some that are considering changes. What suggestions might you have for someone that's considering maybe getting out of the design side of things and getting maybe into that intermediary or on the construction side of the industry?
Well, I think changing course mid-career can be a tough journey. A lot of times it's almost like starting over from scratch. You kind of got to prove yourself over again, but it can be worth it. And it can help diversify your experience. Working with the fabricator or an erector can give you some very valuable experience. And one of the things I was warned about in college was becoming a paper engineer, somebody that can make something look good on paper, but it's completely unbuildable. And really, you have to have that experience to avoid that trap, because you can, like the example we were given in college was the engineer that shows a large built up plate column and shows it being fillet welded from the inside, or just shows a fillet weld symbol both sides. Then the my professor at the time joked about the welder that has to get sealed inside the tube. Well, we sacrificed a welder so he could finish your welds the way you showed them. But if you've actually done some welding, or if you've actually worked in a plant that does welding, then you catch things like that. And so I think that's helpful for people considering a mid-career change like that. Is it can give you that perspective from the other side that maybe you come back to, you work for a fabricator for several years and then come back, you'll bring that experience with you, and it'll make you a better engineer. because
completely believe all your experience, no matter what it is.
yeah.
Every time I go on vacation, I get elbowed at least once because I'm looking at something that somebody did. And I
Yes.
get you're not at work right now. I'm like, no, but look what they did.
Yes. I think every engineer's spouse has to do that at some point.
At some point.
Yeah, you're on vacation. Quit looking up, or quit looking down, or whatever. Yeah, can't help it.
And maybe I prematurely asked you that question because it may have been your power of experience comment that not being a paper engineer. But do you have something for the listeners that may be like an aha that you've experienced sometime in your career that you still use or leverage?
I don't know. I think that's a big part of it is just trying to always balance theoretical with practical. Um, you know, one other thing that I've learned as far as, I guess, maybe what not to do, or advice for engineers just starting out. When I worked at the joist plant that I worked at for 10 years, there was, I mentioned that I had become engineering manager at one point, and there was kind of an unwritten uh, assumption, I guess, that if you became an engineer, then the natural progression was to go into management, because managing people and managing numbers are so similar, and such similar issues between the two. But they didn't really have a kind of defined uh, training or mentoring program. It was just assumed that that's what you were going to do, and so I did kind of fall into that trap of assuming, well, I guess that's the next step for me. And uh, they didn't have the training, and I didn't have the people skills, so it was a very bad combination. So I would maybe just warn up and coming engineers, don't feel pressured to climb the corporate ladder unnecessarily. Um, you know, expertise requires experience. So if you're constantly moving up the rungs, you're never actually gaining some time and grade at that previous position to really have good experience there. So I would just say it's okay to be a good engineer for a long time if that's where your skills are and that's what you're comfortable with, that's what you enjoy. Those are the people that we look at years later and say, man, how are we ever going to replace that guy? Because he knew everything there is to know about joists or connections or seismic design or whatever it is. So I think a lot of times we kind of feel the need to keep moving up and maybe get out of our experience, out of our background, and it's always good to stretch ourselves, but don't feel like that's required, I guess. Yeah.
I think that's great advice. I completely agree with you. And I probably wish somebody would have told me that early in my career too, because it was, and if you think about it, coming out of high school, it's like, okay, now you're going to go do this, you're going to do that. And you want to keep climbing. And then you get into the industry and it's the same thing. Like, what can I do next? What can I do next? And not necessarily saying, what can I do better? Or what can I value and what value can I add without going to that level? I've worked with a couple people that they had no interest in being a manager. And they made that perfectly clear. And then I've worked with other people that are like, oh yeah, I guess I'll do that, and hated it, but still did it kind of not that great.
And I think I was in the second camp there.
And there have been points in my career where I have too.
Yeah, I did it because I felt like that's what was expected of me. I didn't like it. It was the most stressful time in my life. and I tried my best, just like I do on my engineering work. I tried to give it my best, and it's like, I'm failing at this, and the company is suffering from it. My health is suffering from it, and this isn't working out good for anybody. And maybe I just need to accept that I'm a good engineer and I enjoy engineering, and leave it at that for now. And maybe, 10 years from now, maybe I'll be in a position where, being a manager would be appropriate, but not right now. And that's
Right.
okay.
So
So,
we appreciate your time, your valuable insight. I know you were a little nervous coming on here. I feel like that was a very casual and very insightful. You shared a ton of information, and I'm sure that the listeners will appreciate it. Is there any, and as I said, we will link to the actual articles in Structure Magazine for the listeners that want to read all the ins and outs of what you've written. But what's the best way to get a hold of you, or maybe contact you, follow you, connect with you? Uh, because I'm sure
yeah,
you're not the only one, and you've probably spurred some people thinking some things today, and I always appreciate that.
yeah. They can reach me at my office email is jmccool@robbins-engineering.com, or they can reach out to me on LinkedIn. Um, just look for Jason McCool at LinkedIn, and you'll see the Chrome Dome in the profile picture, I think. So
Okay.
um, either way is fine.
All right. Well, I appreciate your time. Thank you for being here.
And I'm also on the editorial board of Structure Magazine, so you can also find me at Structure Magazine. So
Okay. Well, like I said, we'll link all that in the show notes, and I appreciate your time. So thank you for being here.
well, thank you.
Please remember that you can find the show notes for this episode at engineeringqualitycontrol.com. Just look for episode number 10. There you'll find a summary of the points that we've discussed, along with the resources and the links to Jason's article in Structure Magazine, along with ways you can get connected and contact him. Until next time, friends, I wish you the best in all of your engineering endeavors.